Okay, after finishing the functional analysis, we start the architecture phase, and so we begin with a model transformation. This means we map all those logic actors to physical components. So first we again use the wizard, select SGAM Toolbox as technology, and choose that we want to have an SGAM component layer. Okay, so the wizard creates a package for us, and this package already has a few elements which show us how to use. So here we get an actor mapping model. Let's open it. This shows us mapping of a few test actors to some devices. So what we do is we delete all of them because we don't need them. We have our own elements. Sorry. And then we don't need as well. Okay, this we leave for now. So what we do is we take all of our actors we identified, the logical actors, from here. We place them to this diagram. A little bit of layouting again. So, okay. And now I want to decide how these actors will be realized by physical components. So the first one we have is the combined heat and power plant. Okay, we assume that the CHP consists of the generator, which generates the energy, and a dedicated control system, which is realized by a device. We say it's a CHP controller. Okay, so the controller is associated with the generator, and we depict the transformation from the logical actor to the physical actor by a trace relation, so like this. Okay, so this is our physical realization of the CHP. Here we have the distribution management system. The distribution management system, we assume it is at least a computer. Okay, call it DMS. And we say it's a dedicated piece of software running, call it DMS controlling software or something like that. So, software application, here we go. And we say it's DMS controlling app. Okay, it's the DMS. The DMS computer hosts the software. So here we get the hosts relation. Okay, and here again the trace. Okay, so the physical implementation of this logical actor is piece of software that is hosted at this computer. Okay, then we have the energy management system. Here we assume it's maybe it could be a control system, so we say it's a device again. We call it energy management system. Okay, this is the energy management system. Again, a trace relation. Okay. Then what else do we have? We have the heat pump. So the heat pump is again we have a heat pump controller. So it's a device. Controller. Okay, and for the heat pump here I don't have a dedicated symbol, so I just take any physical component. So I stereotype it as heat pump. Okay, I also name it heat pump that way. Okay, so it's just a simple node which represents a physical component. Put a trace relation again here, and here I have an association between the controller and the control system. Okay, same thing with the thermal storage. I assume that the thermal storage has some control logics, at least for communication with the sensors. I call it storage IED. IED means Intelligent Electronic Device, so this is the device that is able to read some temperature sensors and communicate the values. Storage IED. And again, here I put a physical component in and I say this is the thermal storage. Okay. Trace relation. And here I have physical connection. We say it's an association. Okay. So now this isn't very fancy, not to have these pictures, and it's not very good representation. So I want to have graphics for these elements as well, which is very easy. So let's say for the thermal storage, I prepared some graphic in Microsoft PowerPoint. It's very simple. You also could make a picture from the screen and paste it here. Then I copy this picture, say copy to the clipboard. Then I go back and I say appearance, apply image from clipboard. So it's very easy to get a more speaking image for this. Another way, if you use this more often, it's also very interesting. So I do this back, I say select alternate image, no. Okay, so I do the following. I use this graphic here. Oops, sorry. I use this graphic and I say save graphic just on the desktop. I save it as enhanced meta file. Say this is storage or general storage. Okay. Save. Okay. And now I define my own stereotype. So I say settings, UML types, make a new one. Say stereotype is thermal storage. My class is coming from a node. I want to assign an image. I select the meta file we placed on the desktop. Here it is. Okay. And save. Okay, that's it. And now if I put it to the stereotype, if I say properties, stereotype is thermal storage, then we automatically get this image. So it's very easy, but it's quite useful to get speaking diagrams. Okay, I'm doing something similar with the heat pump, which is a variable load to me. So I define my stereotype, UML type stereotype, new one, say variable load, base class and node again, select an appropriate image. I already defined variable load. Okay, close. Oops, sorry. Save. Close. Now I change the stereotype to variable load. Okay, and here we have an appropriate icon now. Okay, so now we can start to develop the component layer. So what we do is we create for our high-level use case, we want to depict on component view and our package we already have one. I call it let's call it heating system. Okay. You can choose on yourself if you want to make one component layer that depicts all, or if you want to separate various views. It's depending on the system and the complexity, if you prefer one diagram or more. I choose to create an own diagram for the heating system. So we go to the component layer, it's also here, open this one, we want to have our matrix again, so diagram, swim lanes and matrix, we say SGAM component layer, yes, active, okay, and now we can place our components here. So what do we have? I put in everything first, except the software application, because here I'm only interested in the computer that is hosted. Okay, then let's look. We know from the function layer that we will focus on distribution in DR, so I'm going to resize here a bit. Okay, customer premises, not. I'm not sure if it's 100% correct if I locate all the things here in DR. Maybe terminal storage should be located in customer premise, but for demonstration purposes of the toolbox functionality, I think it's okay to do so. Okay, so we know we have some terminal storage here, make it small. We're interested in the controlling system here of this terminal storage. Okay, then we have do we have here, this is the heat pump. Okay, communicating. Okay, so the heat pump, then we have the flexible load, oh sorry, it was combined heat and power, this is the heat pump. Okay, the control system. Okay, just make these a little bit thicker just to better see. Okay, again this one. Okay, here we have the energy management system, which we say somewhere like here, and operation we want to have a little bit bigger. Okay, we say we have the operation here. Okay, fine so far. Okay, now we can start to finish modeling of the SGAM plane here in the component layer. So I start with a transformer in the distribution system from medium voltage to low voltage. Okay, and now we have electric connections between these elements. I can directly draw the electric connection, but I prefer to make an electric network element, so I call it low voltage, because so I always see which elements are all connected here. It's quite useful. Okay, this is my low voltage network here, and I have electric connections from here to there. Okay, and to here, and to here, to the generator. Okay, so I just hide out the stereotypes just to keep visibility high. Okay, fine. So this is the electric system, and then we start with the ICT system. So we assume, as this is all in the same facility, we have direct ICT connections here. Simple make ICT connections between the control systems and the central energy management system. So I say this is the ICT connection, one here, one there. Okay. Again, I hide the labels, just don't want to see them here, but it depends on you if you want to or not. Okay, so we have the next one is the connection between the DMS and the EMS. So this is some remote connection, and here I want to depict that it's communicating through an undedicated SED network, so I introduce this SED network here. I just call it, I don't know, Lexil loads network, I don't know, however you want. And here we have SED connections again. And same thing from here to there. Make this a little bit bigger. Okay. And of course you could make this network here composite and describe in more detail how it is set up. For example, which firewalls are used, who is administrating it, maybe if there are other elements integrated. Depends on the detail you're interested in. But for here it's good just to see this is the used network and this is the communication way for those two elements. Okay, and that's our component layer. Okay, after finishing the component layer, we go on and create the SGAM information layer. So again, we use the model wizard, select the SGAM Toolbox as technology, and here we choose the information layer to be created. Okay, we want to save the other diagrams. Okay, now the information layer is created, and take a look what we get there. We see business context view, a standard information object mapping, and a canonical data model. So we're doing the following steps now. First, we model the business context view. This is where we show which information items or which information objects are to be transported between the physical components. Then in the standard information object mapping, we try to identify which standards are suitable for the transported information objects, and in the canonical data model we are going to show in which areas we will use which data models. Okay, let's start with the business context view. Okay, we already get our frame here. Okay, so what I do here is to make life easy. I simply copy all the components from my component layer here. Sorry. Okay, so I only copy these elements here, which are involved in communications, because these elements here in the electric system are not involved in communications, and so I can keep the place compact. Okay, simply copy business context view, just paste them here. Okay, arrange them in the way, and so we are again in distribution here, so somewhere like this. Okay, so this is the way. Okay, what I'm going to do here now is deleting this network, because for information object flow this is transparent, so I'm only interested in which information is transported from here to there and not by which way. So just delete it here, and also I don't want to see these physical connections, so I can make them transparent. So visible relations, just take them away. Okay, so now I want to show which information objects are to be transported among these systems. This information is already available in the model in the function layer when we take a look at the description of the primary use cases. So for example, operation plan. Here we see on the logical level which information items are transported between these logical actors. So what we are doing now is we simply analyze these diagrams and put this information to the information layer. This step is quite a copying task, so I want to automate this in the future version of the toolbox, but for now you have to do it manually. So we've seen the first information object flow was an authentication from the energy management system to the distribution management system. So we already have the information object created. We simply select it. It's here in function layer information objects. So we know it's the authentication credentials which are transported. So here we go. Okay, information object. Some reformatting. Okay. What I'm going to do now is I move these information objects here to the SGAM information layer, because in my opinion they fit better here than anywhere else. Okay. The second information object flow was the transmission of the energy price table. So again we use an information object flow, this direction now. We select the energy price table. Okay. So this is the beginning. Remember, this is the task that happens once every 24 hours. Just put it there. You can draw pretty diagrams if you have time. So, okay. Then we start the continuous operations. So we know in the beginning we have the data acquisition from the storage. So we have some information object flow from here to there. We select the right one, it's the storage temperatures. Okay. Storage temperatures. Just fit them a little bit. Okay. And then what we have next is the communication of the set points for the two energy generating units. So we have once information object flow from here to the combined heat and power plant, the operating point from here to there, and same thing from here to there for the heat pump. Here we have the heat pump operation point. Okay. And again, please remember, you have these information objects here are physically linked to this communication element, so you can always say find items conveyed, and you will get the physical the logical information object that is linked to this communication flow. Okay, and now that we know which information objects we want to transport among the components, we try to identify which data standards are suitable for that. So what I do now is I copy these elements to make life easy. I go to the standard and information object mapping diagram, which is already created by the wizard. Open this diagram. Okay, just paste my elements here. And now I'm browsing through, and here I see, okay, I start with the communications between these two components. I see, okay, find items conveyed. I place the conveyed information objects in a diagram. Here it's the energy price table. Okay. So I need to find both of these components need to understand a data model standard that is able to hold these information objects. So for the communication between these two elements here. I don't know any standard now, but no matter. I simply say we have a proprietary standard, something like my energy price standard. I don't know. So both of them must be able to understand this standard. So I say they associate the standard. Here again. Okay. Okay, and this data model standard must provide these two information items. So provide information object relations, one and the other one. Okay, here I hide the labels. Sorry, it's the wrong relation. Provide information object, it's this one. Okay, and hide the label. Okay, and now we have linked the data model standard to both of these components. Okay, let's go to here. What do we have here? We have communications between the energy management system and the thermal storage ID, between the EMS and the CHP controller, and between the EMS and the heat pump controller. Let's say for now all the communication between them is done by OPC UR. So again, I find my items that are transported, so the storage temperatures. Okay, then I have, what is this? Find items read, it's the operation point for the CHP, and here we have the operation point for the heat pump. Okay, make them the same size. Okay, so let's say for example the underlying data model standard, I don't know, we use something like OPC UA or something like that. For now it doesn't matter what I select, I just say it's OPC UA, even if this is not completely correct. For now it's okay. Okay, so I make it that way, and now I know all these components must associate this standard. So associate data model, this one, this one, this one, and this one. Okay, make it that way. And this data model standard must be able to provide these information objects. This one, and this one. I hide the stereotypes here. Okay, and now we have identified which data model standards have to be used from the components. Okay, the last thing we do is to put the data model standards to the SGAM plane. So we switch to the canonical data model. We open this here. Oops, sorry. Okay, so we also have here our matrix from the beginning on, and again I just copy those elements here. These one I don't need, sorry. It's a little bit tricky because my screen capturing tool compromises my mouse, but so it's also fine. Okay, let's open this here. Okay, just arrange it the way we know. Okay, don't need this one as well, this one is not necessary, and we're here. Okay, so actually I'm not interested in this view in the connections we already have, so I just make them invisible. Don't need any of them. Okay, and now I know we have here in this area we are communicating using OPC UA, we said, even if this is not completely correct here, no matter. And in this area we are using our, I don't know, our proprietary standard. So, okay, and that's it. Okay, that's the information layer. Okay, and the last layer we have to model is the SGAM communication layer. So we use again our wizard to create this layer. We select SGAM Toolbox as technology, and here the communication layer. Okay, save the diagrams. Here we got the communication layer. If we open this diagram here, we see that we already have our matrix included. We just resize it to fit our needs. In future versions we plan to make the location of the elements automatically, but for now you have to do this manually. Okay, so I'm going to copy my elements from another layer again to make life a little bit more easy, so I copy them from here. Okay, go to the communication layer again, and here I can paste my elements. Okay, here we go, and here I want to show the communication technology and the protocols, so I'm not interested in these relations, so I just make them invisible. Okay, now they are gone, not in the model but just in the view here. And now I can start with my communication paths. So we have one communication path between the distribution management system and the energy management system. We have one from the energy management system to the storage ID, one to the combined heat and power plant, and another one to the heat pump. Okay, so here we go. Now we want to show which protocols and which technologies are used for communication. So let's say for the communication between the distribution management system and the energy management system, our protocol is a web service, for example, and the technology is Ethernet, I say. Don't mind. So okay, here we go. Here we have OPC UA. Just copy this here because we have the same thing here and here, and the technology is, let's say, Ethernet as well. Okay, just copy it. So Ethernet and as well Ethernet. Okay, not very readable now. Just make it bigger. Okay, here the same thing, and here. Okay, this is how the communication layer looks like. So as this was the last layer, take a look again at what we have and what we can do with this model. So let's start here. We have all the layers. In the business case analysis, we see the motivation for why we built the system, who are the stakeholders, what are their interests, what will they do, and what are the use cases. In the function layer, of course, we have all the use cases described in detail, especially the high-level use cases. We can see how they are running. We can see the use case diagram, so which actors are involved, and we can see in the SGAM plane which domains and zones are affected by these use cases. Of course, we also can see description of the primary use cases. Again, here the operation plan. You can see the description of each use case. Normally you would be able, just open this here, just to double click the elements and come to the diagrams, but as my mouse is compromised by the screen capture tool, I have to navigate here through the project browser. Okay, so we have a complete functional description in the model, and starting from this functional description we go down to the architectural description. So we have the information layer. We see all information objects here that are used anywhere. If we click on any one of them in the traceability window, we see exactly where this object is needed, where it is provided. We have the traceability. In the business context view, we see where these information objects are transported. We see the information standards that are used, and here again we see the information standards mapped to the single domains and zones. Below this, the communication layer shows us the technology and the protocol used for the communication between all these elements. And here in the component layer, we finally can see the physical structure of the system. So you see the model is it provides a quite good documentation. You see the interfaces on all layers between the elements, and so this is a quite good basis for cooperation between maybe two teams that are working, one team on this element and the other team on this here. So what you could do with this model now is, of course, you could generate HTML reports. It's easy, you just click here and say HTML report, then you can click through your whole model by using a browser, so you don't need any tool or something. You could generate very fancy documents that can be used as documentation and that represent the actual state of the model. So as the model is the subject we are working with, the generated report is always new, so you don't have the problem that the documentation is old or doesn't correlate with the system. So the toolbox here, if you go to the resources view, it also provides various templates for documentation here among SGAM Toolbox. But generating reports is a quite interesting issue, but I think you will find enough information about that by using the help, or maybe I make a second tutorial for that, I don't know. Okay, what can we do now with the model to work on? For example, let's assume we are the guy who has to develop this IED here, which is able to fetch the data from the terminal storage and which should be able to integrate in the system here. So we can do the following. We just take this element, I copy it, I say okay, now I want to take a look into this black box. I make a new diagram, say make it composite, make a composite structure diagram. Okay, I open this diagram. Now I paste my element here. Okay, and now I want to see this is the system I'm interested in. I have to build. I want to see what is the system context, what does the system has to fulfill. So I take a look at the related elements and I say, okay, let's put everything into a find. So I see the following. I see on the one hand, I have to be able to understand this data model standard. Okay, fine. I see that the control system has some relation to the channel storage itself, and that the system has various communication mechanisms. Here, put this here, with the energy management system. Just make it a little bigger. Okay. So, for example, just make it that way. Okay. Here in this layer, this relation is the one we developed in the communication layer. So I see, system needs to be able to communicate OPC UA via Ethernet. Then I see that these information object storage temperatures need to be communicated from this device to this device, and to do so an ICD association between these two devices exists. I could describe this in more detail, for example, if it is, I don't know, if there are routers or switches or something like that. I just made here for the ease of the example only one ICD association without any routers or switches or anything like that. Okay, the associated data model is the same on both sides. Okay, and this is what the system needs to do in the physical structure. Here I see the logical actor that is realized by our system we want to build. So this logical actor tells me what the system has to do. So again, I use this actor and I insert the related elements. Okay, and so I see, okay, this is the, in our case, this is the only use case I have to fulfill, I as a system. Okay, so it has to fulfill the use case data acquisition. Okay, and if I take a look at the data acquisition use case, insert related elements. Okay, I see with which other use cases it has to do and which other actors are involved. Okay, here again the EMS. Okay, sorry. What I don't see now here, this is because the demonstration example is very made in a short way. Behind this data acquisition use case is a whole description. So I say make it composite, new diagram, select composite diagram. We already described this data acquisition use case. Here, function layer. Okay, with this diagram, okay. So, and now if I double click, okay, sorry, my mouse doesn't allow me to do so, but without my screen capturing tool, if I double click here, I see the whole documentation of this use case. So this is a very good overview on the whole, on one picture, to see what my storage ID has to be like if it wants to be integrated into the other system. Oh, there's one thing I forgot. I forgot the information object I want to see. This one is here. This information object is transported. Okay, here it is again. I leave it here. No worry for now. And typically here I see the information object is labeled storage temperatures, but here it should be described in within the nodes or in the tagged values that the storage temperatures means, I don't know, 3 sensors, I don't know, the value is in degrees Celsius and whatever. Okay, and that's how we start architecting this system. Now we know the system context, what it's all about. And then we can say, okay, we start with the design and with the detailed architecture. And for example, I make a new model, create a new component. For example, I don't know, let's say I create create a new diagram, let's say a component diagram, for example, structural component diagram. Okay, here we go. And here we say, we start, okay, with this component, this is the realization of this ID, and maybe it has new parts, so I can say, okay, I have an interface to the maybe a data acquisition interface. This interface is used to get the data from the storage, so I use it to create, I use it to create the new port here. So okay, this is my DAQ port. Okay, so here I got this new port, and then I say I need new components. For example, I don't know, I get a new, I have to do it other. So, for example, I make a new component inside here. One is the data acquisition module. This is here, it's connected. Sorry. Okay, my mouse is a little bit annoying. Here we find the data path. For example, I have some pre-processing unit, I don't know, and some communication unit. Okay, this is my communication unit, and here we can show, for example, a data flow graph. So here we get another interface for communication. This goes towards the energy management system. Okay, communication. Maybe we get one, I don't know, we have a business logic. However, okay, business logic here controls all those other modules. Let's say this is the data flow graph, which we make maybe that way. Source destination. Sorry. For example, let's say the data flow graph will be, I don't know, maybe it's this color. Same thing here. So this color, thick. Again here. Okay. I think you get the idea of what I'm trying to show. Make it that color. Okay, so you simply can start to decompose the one device into sub-modules, which you can start architecting in the way you want. So the business logic maybe here is the control logic, the software. This is a hardware module that must be able to read maybe P2000 sensor values, or I don't know. Here you can start with classic systems engineering. But we simply take this one here, go back to this diagram, can say okay. Again, the trace relation, this is a transformation from the architecture to the design. And here we say this is the element within the SGAM context, and this is the design of this element. Okay, so that's all for now. I hope you could get a little imagination about what's possible and how to use the toolbox, and I would be very happy to get some feedback how you use it, if it is helpful, if you have some feature requests. And so if we can help you somehow, just write an email to christian@ian-trust.at. Thanks. Bye.